Hello, thanks for joining me. Today we're going to use completing the square, the process, to rewrite the equation of a circle. So this recording will be neither fish nor fowl. We're going to be looking at kind of a multiplied out version of the equation of a circle. This is one of our conic sections, but it's been given to us in this expanded form so that it's really hard to tell anything about the circle. We're not really going to focus on that. We're going to focus on how do we get it into the more standard form for the equation of a circle so we can tell stuff. So first of all, we'll give ourselves a little bit more space. It's going to take some space in doing here. We're going to rewrite the equation with the x terms gathered together. So x squared minus 6x. And then I'm going to leave myself some space here. And then plus y squared plus 4y. I'll leave myself some space there. I'm going to go ahead and move that negative 12 to the other side. So I'll say equals, add 12 to both sides, equals 12. Okay, so our process is we're going to do completing the square with this group right here, and then again with this group right here. And remember the process of completing the square, you simply take the half of the coefficient of the single x and you square that and add that to both sides of the equation. So half of negative 6 is negative 3 squared is positive 9. We'll add 9 to the left side of the equation and to the right side of the equation. And we'll do the same thing with the y group there. So we have a plus 4y. Half of 4 is 2. 2 squared is 4, so plus 4 to both sides. Now, completing the square, I like to, oftentimes I'll do this ahead of time. I want this to fit in the form a minus b squared, so it's going to be x, and then that half of negative 6 number is what's going to go down here. Half of negative 6 is negative 3 squared. Now, I trust you know a little bit about completing the square and about multiplying binomials to check to see that that is true. But that's the steps for completing the square. Okay. We'll do the same thing. Y plus half the number in the middle, cut in half, so plus 2 squared equals, and then 12 plus 9 plus 4 is 25. And there we have it. That's our circle in standard circle form, conic section form, where the center of the circle is located at 3, negative 2 on the Cartesian coordinate plane, and the radius is equal to 5. That's 5 squared is at 25. Okay, so that'd be really easy to graph or just talk about the location and the size of that circle. Let's try another one. Alright, now I advise you to hit pause and try this yourself. It's the exact same type of problem. Try it yourself and then hit play and see how I do it. Alright, so we're going to do x squared plus 10x. I'm gathering my x terms together. Leave a little bit of space. Y squared plus y squared plus 2y. Leave a little space. Add the negative 17 to both sides. Okay. Then we're going to come in here with, let's see, change our color here. So we're going to add, we're going to take half of that number squared, so half of 10 is 5, and 5 squared is 25, so add 25. Didn't give myself much room there. And same thing, half of that number, half of 2 is 1, 1 squared is 1. Alright, and that's enough to do my completing the square with this group here and with this group here. Okay, so I have x plus that half of the 10, which is the 5, squared. Just pause that and try it out and see if it works for you. And y plus half of that 2 there is 1 squared equals negative 17 plus 25 plus 1, and I think that is 9. So we can tell that the center is at negative 5, negative 1. Remember, it's the opposite of the numbers you see there. And the radius is equal to 3. It's always the square root of that number in that position. And that's how you use completing the square to rewrite your circle formula in a way that allows you to really tell something about it. Let's do one that's not a circle. Okay, here's one. How do we know it's not a circle? Well, we can see that we have a coefficient in front of the x squared and in front of the y squared, which was different than the last two problems. It would have been okay if we had coefficients there, and it could have still been a circle, but not if they're different. So if the coefficients of x squared and y squared are different, then this is not a circle, this is something else, and I'll give it away and say it's going to be an ellipse. But we'll do this the same way. So we'll say gather the x terms together, 3x squared minus 12x. We'll add something else there, but we don't know what yet. Plus 5y squared minus 10y plus something else. We'll add something else there. Oh, you know what? We're going to do a different step first. So I'll go ahead and subtract the 2 from both sides. Okay, before I can do that step of adding something to both of these and getting my completing the square, we actually have to go to the real first step of completing the square. Okay, the real first step of completing the square is you want to take that first coefficient of the x squared and make it 1. Normally, if it's just a regular old equation, it's pretty easy. You just divide by that coefficient. But since I'm only going to complete the square from there to there, I'm only just completing the square involving the x terms, the way I'm going to do that is I'm going to take out a 3 and then what's left over just for those terms. So x squared, 3x squared divided by 3 is x squared, and negative 12x divided by 3 is negative 4x. And then I'll put my little space there to add something. I'll do the same thing with the y values. So I've got a 5 next to y squared, so I'm going to take out or distribute out that 5. And then everything else stays in there. So y squared, negative 10 divided by 5 is negative 2y plus, I'm going to add something else there, leave a space for it, equals negative 2. Okay, we're all set and we're ready, but we have to think about this. When I add something here, I'm adding something there, but that something is going to be part of what is getting multiplied. Something is part of what's inside the parenthesis being multiplied by the 3. So if I add a number there, and let's just say what it is, it's going to be 4, right? Half of 4 is 2, negative 2 squared is 4, so I'm going to add 4. But if I finish the math off, I'm going to end up multiplying 3 times that 4, and so what I'm actually adding in that spot is a total of 12 to the left side of the equation. So the left side of the equation is getting added 4 times that 3 to that little expression there. It's going to make 12. So I'm going to add 12 to the right side to balance out that 4 times 3 on the left side that I just brought in out of nowhere. Same way here, I'm going to take half of -2, which is -1, square is +1, so I'm adding 1. But then within that little trinomial, I'm going to distribute the 5 times 5, so I'm actually adding a total, bringing a total to the table of +5. So I'm going to say +5 over here. Okay, we'll complete the square now. So x squared minus 4x plus 4 is really, let's erase this, is really x minus 2 squared, and remember we were multiplying that times 3, plus the y squared minus 2y plus 1 is really y minus 1 squared, and we were multiplying a 5 times that, equals, so we had -2 plus 12 plus 5, that's 15. Alright, and then the last step is to, this is an ellipse. Remember, in the form of an ellipse we actually have our x minus something squared and y minus something squared as fractions over some number. Each one's a different number, and then it all equals 1. So we want this all to equal 1. I'm going to divide everything by 15, so divide each part by 15. And I get a 1 there, of course. And let's see, we'll start from the left. So 3 over 15, we can reduce that fraction, cancel out the 3, divide out the 3, we get a 5, so this becomes x minus 2 squared over 5, plus, same thing, divide out of 5, this time we're left with a 3, so that's y minus 1 squared over 3, and clean that up a little bit. 15 divided by 15 is equal to 1. So this is an ellipse. This is the form of an ellipse. If you remember our ellipse formula, it has a center at 2, 1, and so we find 2, 1, and the horizontal distance out is going to be the square root of the number 5. The vertical distance up and down is going to be the square root of this number 3, and so our ellipse is going to kind of look like this. Obviously not really trying to do a good job on that, but that's how you use completing the square to take an expanded form of one of these conic sections and rewrite it in a form that allows us to kind of describe the graph a little bit more accurately. So thank you for watching. Hope that helped in your completing the square pursuits.